Okay, good morning and good afternoon and good evening to folks that are joining this exciting webinar. This is Sakid Ahmed, and I believe I have my camera on, although I can't see myself, but welcome to everyone. Quick introduction on myself. I run the ePMP product line, and today I'm joined with Bruce Collins and Dmitry Moisev, who I will pass the microphone to here shortly. But we're just excited to talk a little bit about our 6 and 5 gigahertz AX portfolio, give a little insight on what we're up to, what we're doing, a little bit of the technology, and a little bit more detail around the overall program. So with that, Bruce.
Thanks, Skeet. Thanks everybody for joining today. I'm in the product management team responsible for the ePMP portfolio, working with Sakid and Dimitri. So yeah, we're having a great session today. We hope to get a lot of your questions answered. So please feel free to put those in the chat window as we go, and we certainly keep this interactive and hope to answer some questions for you. This next generation of ePMP is an exciting one. We're not actually announcing the product today, but we want to give you some insight into how the progress of the development is going, some early sneak peeks at some of the data that we're seeing, and really looking forward to as this program develops.
With that, the infamous or famous Dmitry Moisev.
Hi everybody. Yeah, I'm in charge of the software. So if you have any tricky questions regarding the ePMP software or any functionality that you are missing, so please shoot them in my direction.
Oh boy, Dimitri, you just opened it up. Functionality requests.
Oh yeah, sure.
This is going to be fun.
That's my favorite topic. So.
All right, super. So hey, Bruce, with that, I'm going to let you kind of cover the initial part, maybe kind of go through the first few slides, and then we'll jump in. Let me know when you switch slides.
Yeah, and I see we have one more panelist joined. Joe, are you there? If you want to introduce yourself real quickly.
Yeah, hello, I'm Joe Steffen. I'm ePMP hardware manager. So all your hardware problems, you can blame me.
Joe. So, there you go.
Well, we appreciate all the work. The hardware on ePMP just continues to get better and better, and we're really excited about the industrial design and where things are headed with this platform. So yeah, we have Joe to thank for that. So again, if you have questions about the hardware, whether it's what's inside the guts or what's on the outside, fire away. This will also be recorded, so you'll have a chance, if you want to go back and listen to it, you can do that and go on to the community. We hope that this call triggers some conversations on the community, and that's always a good place to interact with the team that's on the panel here today. But let me just give, I'll call it 3 or 4 minutes of background on ePMP, because I know we have a really large group on the webinar today, and some of you may be new to ePMP. So I want to just hit that real quick. We talk about why would a WISP or service provider or enterprise private network operator pick ePMP, and we really kind of narrow it down to these 4 areas. We talk about 802.11 AC Wave 2, which gives us 4x4 Moomaimo, the wider channels and the higher modulation. And now today we're going to talk about where things are headed, but this is the capability that's out there today with Wave 2, and it gives us some great performance. And we have the deployment rate of ePMP just continues to go up, so very excited about that. The key differentiator with ePMP over some of the other peers in this space is the scalability and interference tolerance. So over time, as the sort of baseline of ePMP was this synchronization and very solid capability to scale up the network, that continues to be sort of a key foundation of the platform as we move forward. We've also added things like the dynamic filtering and some other enhancements in the air interface and how that works. we offer compatibility. So if you install an ePMP 3000 access point, it will talk backwards compatible to those 11N devices. So whether it's a Force 180, a Force 200, it'll talk backwards compatible. And you're going to hear more about the compatibility story as we go today, as we go to the next generation as well. So we offer that convenient path from the legacy of 11N to 11AC Wave 2, and now moving forward into 11AX. And then just as important as all of this is what is the total cost of ownership of ePMP. And keep in mind that we offer a 3-year warranty on the hardware, so that you have peace of mind as far as putting these radios up, that if you do run into a problem, you've got 3 years of warranty. And then also you have support direct from your channel provider, whether it's a distributor or reseller. And then of course you can come straight to Cambium for support. And also you've got that whole community, tens of thousands of WISPs around the world that are using ePMP. So you've got this big community of users as well, but you can always also go straight to Cambium for support. So go ahead, Sagid. So this gets into a little bit of the longer term strategic benefit of deploying ePMP, and you're going to hear some of that payoff on that investment today, where every Force 300, we call them 802.11 AC Wave 2, or simplified as the Force 300 subscriber module series. Every one of those that you deploy today will be interoperate with our next gen 5 gigahertz solutions. So this gives you a path towards next generation. You're not talking about forklifting or changing out. So some of the competitors swing back and forth between, am I running something like an LTU or an 802.11 based system? You've got a nice convenient path forward from the current technology to the next generation of technology. We are fully invested in Cambium. We're fully invested in Moomaimo. So you're going to see the benefits of those investments in multi-user MIMO, and that will continue as we go into the next generation. And you see that in our other product lines as well. But multi-user MIMO is really the one of the foundations alongside synchronization that really sets Cambium products apart. So you can go ahead, Sakid.
Yeah, I think, Bruce, I wanted to add a quick comment on that just to build up the story that you're highlighting, is that the compatibility has been a anchor feature for us for a while, and it's certainly been a challenge across the board in some cases when we went from 11N to 11AC, but we're still very committed to making sure compatibility continues to be a supported feature. And what that translates to is an investment protection for the customer base out there. You deploy a subscriber, you may not get the same benefit as the latest generation subscriber, but you're not forced to go drive over and do a truck roll just because the AP has changed. So that gives you tremendous flexibility to take time in upgrading your network, being selective on which subscribers you upgrade. And in some cases, there are some benefits when you interoperate, but fundamentally, it's just a flexibility and time that you're getting in order to upgrade. And this has been one of our strongest selling points, and it's a key attribute that I want everybody to take away from this. The second comment, Bruce, I just wanted to add, and I think you and Dimitri will agree with this, is Moomaimo and Massive MIMO, as proven by our Rssi and Medusa platform, now with ePMP 4x4 going to an 8x8, continues to be one of the most compelling technology out there that gives you that spectral efficiency, packing more bits per hertz, right? That's the end game. But what is interesting that I want to highlight is you notice that when we went from 11N to AC, we went to 256 QAM. Well, today you're going to hear about higher order modulations as we talk about 6 gig. And the stance from Cambium is you could go down the path of just talking about higher order modulations, which some of the competing platforms do. But we know the answer there is that you have to have very clean spectrum and very high RSSI and good SNR to get that higher order modulation. However, a combination of higher order modulation as well as multi-user MIMO starts to bring together a very, very compelling solution. So as we talk about 6 gig, that's something we'll touch on. Thanks, Bruce.
Okay, and just to kind of set where we are with the current portfolio, we have a number of different access points, but you'll see as you look at this chart, I want to highlight two specifically. The ePMP 3000, which is our current flagship access point, this does have that multi-user MIMO 4x4 up to 100 SMs, and then its little brother here is the 3000L, which is a 2x2 MIMO solution, which makes a nice solution for some sort of narrow sectors, or I just want to drop in a little bit of extra capacity or extend the coverage area of the network. Those are really the two primary access points that people are deploying today. We do offer that Omni micropop over there on the right, and you'll see the migration towards the AC products and then onwards into the future here as well. So those are the two I would highlight. Go ahead, Sakid. On the access points where you've got the 3000 over there on the right, there are a number of different options for how you deploy that. So always keep in mind that while the prototypical approach is to use 4 sectors with the multi-user MIMO in sector antenna covering 90 degrees, and you cover that in four sectors. We have a lot of customers also using our, over there on the right, you see a Moomaimo dual horn antenna. This has become quite popular amongst the deployments with the 3000, where you can get the advantages of it, of the antenna pattern of a dual horn, where I sort of have smaller side lobes. I can point that out into a narrow sector, and I can really light up, say, a small grouping of cluster of homes or businesses that I'm trying to hit, and really gives you that nice small form factor and a nice tight performance on that dual horn antenna. Then, of course, there's some third parties like KP and IT Elite that do Omni antennas, and those are true Moomaimo supporting Omni antennas. So you've got those options. And then in the middle there, you see the 3000L. You've got options from Cambium in either the sector antenna, and then there's any number of 2x2 Omnis out there, as well as our friends over at RF Elements with their twist port adapter, which snaps right on to the 3000L and lets you use any number of their different horn antennas for the 3000L. Go ahead. And then for the subscriber modules, we have a nice portfolio and range of SMs that you can use for a variety of different applications. The primary attribute that you look at with an SM in our portfolio is range. So you've got everything from the bottom right there, the Force 313 with a 13 dBi gain, really small form factor, and then you go all the way up to the Force 325, which has that dish antenna and gives you sort of the best range in a dish form factor. The Force 316 is quite popular, that form factor. We've got the sort of that horizontal orientation of the unit. And then I would also just highlight the Force 319 and 19R. This is really popular with some business deployments where they don't necessarily want the form factor of a dish on the side of the business, but they still want decent range. So you get the 19 dBi flat panel antenna. And then this also has the option of a 19R, which is the full IP67 with some of the benefits that come along with that. So I'll keep moving on that. And I think you can, it's just kind of a summary chart. So I would say we can move along past that. The only thing, I guess I will say one other thing on that. Sorry, Saki. Is it's always worth mentioning that besides the platform with the access points we talked about, the subscriber modules we talked about, the compatibility we talked about, there's also this whole suite of software that we now have. So Link Planner has been available for a long time. That gives us a great ability to do both capacity planning and also availability planning. So if you say I want to offer 200 megabits per second to this customer and I want a certain amount of availability, Link Planner can tell you all the what if scenarios about which device to pick and what antenna to use and those things. You also have CN Maestro, which is the network management system, gives you that single pane of glass view across all of the Cambium products. And then CN Heat, which is the newest in this suite of software, that leverages LiDAR data and LiDAR information to give you more of a coverage planning, whereas Link Planner will tell you the capacity and availability from point A to point B. CN Heat will tell you what are the areas that I could hit if I put an access point at this location, where can I get coverage around that area? So really a nice tool for that. And this is kind of this next product that we'll talk about is really the bridge, if you will, from the current ePMP 3000 into that next generation 4000 technology. And that when you see the 4 in the product naming scheme, that's referring to the 4th generation and also refers to 802.11ax or Y6. So this is a point-to-point product. It's a force 425 and 400C. You can see the images there on the slide. It comes in both a dish form factor and a connectorized. Really gives you the ability to deliver a gigabit per second, or up to that gigabit of usable throughput, low latency, and a nice wide spectrum range. So this also has given us sort of an entree into that 11AX market. We've been shipping this product all of this year, and really been the people that have deployed this have been quite happy with it, and it's giving us a great foundation in that 11AX technology to start to demonstrate the capabilities, get experience with it. So when the point-to-multipoint scheme, point-to-multipoint product using the 802.11ax protocols and schemes and technology, when that hits the market, we'll have all this experience underneath that we can leverage. This also has an SFP module, which really helps as we start to move towards gigabit speeds. SFP and fiber interfaces become that much more important.
Thanks, Bruce. All right. So the next slide I'm going to shift towards is about 6 gig, and we'll start off by a little bit of a vision that we established early on in the ePMP product line. You know, some of you have been around since 2012-13. But as you can clearly see, we've been following the standards more or less, and went from, you know, GPS sync with self-interference, with backwards compatibility ePMP 2000, and then ePMP 3000 with 11AC and 11N compatibility along the way. Of course, third-party device support was done. And then as we move towards the future, this is today. We've shown this slide in the past, but it's really about 802.11ax, adapting and building products around that technology. Very, very exciting stuff. And I think the previous slide that you saw in 425 is definitely really good indication of what this technology can give us, combined with the Cambium proprietary software modules, right? So we're spending a lot of time building a synchronized device, determinism, and custom ARQ, and all sorts of software that you've seen developed over the years still needs to be done on the AX. But underlying chipset and underlying technology of OFDMA and multi-user Moomaimo is definitely something we're excited about, and I think that's going to give our wireless customer base a huge leg in providing that type of performance. So I will move ahead and show a quick chart, which many of you have probably seen, but in summary, your 6 gig to 7.125 is probably the biggest frequency availability plan that we've seen in a long, long time. Obviously, this is still going through some litigation and things like that, but you know, for the broadband connectivity of the world and what the pandemic taught us, you know, we need this spectrum. And the WISPs out there that in North America are facing interference on 5 gig, this additional spectrum really, really opens up a huge opportunity to provide higher bandwidth to end customers. So we're monitoring and we're building products that fully leverage the frequencies and the channels that we are going to get out of 6 gig. Needless to say, the next slide I'm going to show, which is a timeline, but I want to speak a little bit about this, is that 6 gig will have something called AFC, automatic frequency coordination. Those of you who are familiar with CBRS, that was the beginning of shared spectrum model. And I think that's just the beginning, and 6 gig is still not the end. There's going to be more like this in the future. But the concept of being able to coexist next to microwave backhauls and avoiding them is where AFC comes in. There's algorithms that run on the radios themselves that coordinate with the database of microwave entities. And the fundamental goal is to just avoid interfering with the mission critical microwave products. We, as Cambium, are looking at various partners and keeping a very close eye on this system. And we hope that we will have a solution that leverages the best AFC solutions and making sure that you guys are able to operate in 6 gig band very cleanly. And to that end, this is probably in everybody's mind, but when you think about AFC testing and certification, this is sort of a long pole on 6 gig availability. Once you get past the challenges of litigation and things like that, next year, sometime in October, is more or less the likely timeline that we are seeing based on the alliances that are engaged with the FCC. Things can change. Everybody knows in this business, things can shift to left and right. Well, in this case, if anything happens, it may move to the right. But the confidence that I wanted to give to our audience today is that Cambium is very, very closely monitoring and engaging in this timeline. Our software development, our hardware development are all committed to being in sync with whatever the FCC ends up doing in terms of product availability. So that's the key message on 6 gig.
Yeah, I think I just want to maybe comment one thing, Skeet, if you go back to that previous slide, is this is really a US centric view of 6 gigahertz. So there are other parts of the world that have access to 6 gigahertz, and we do expect these products to interoperate and work in those bands as well. You'll also see references in the press to Y6 referring to the underlying 802.11ax technology, but then you'll also see references to Y6E, which relates to the 6 gigahertz leveraging 11ax. So the rollout of where and when you can use outdoor 6 gigahertz fixed wireless is still up in the air. Clearly, the FCC has a plan that they're driving to, and we're in really close coordination with the ecosystem here to make sure we're ready to go. But we do expect that the rest of the world will be watching closely at what happens with 6 gigahertz as not only the chipsets become available with 6E, but also as the regulatory bodies kind of open up this band in the rest of the world.
Right. And then to that point, Bruce, we are seeing that 6C for indoor Wi-Fi low power has opened up in countries like Brazil and a few other places. And I think if we keep monitoring that, we probably will see some outdoor standard power options open up as well. So exciting stuff globally. While this is North America centric, we do see some things happening globally as well. All right, so the next part is probably the more exciting thing, and start to talk a little bit about the hardware, what we are building, what we're working on. So first and foremost, I want to make sure that everybody follows this very, very clearly. The 5 gigahertz AX access point and the 6 gigahertz access point are two different products. The ePMP product line does not have an extended band access point, which will support all the way from 4.9 to 7.25. They are two different APs. You may have lots of questions about that, but I'll just spend 30 seconds explaining that the building a access point that spans the entire band is certainly a challenging undertaking. It's complex, it can become very expensive, and we chose to be in sync with time to market and making sure we have a 6 gig product out at the time of AFC availability. So the choice was to go ahead and do a 6 gig only AP and a 5 gig only AP. I don't want any confusion on this, so I want to clarify that. So what you see on the left is an 8x8 AX AP. Think of this as our a junior CN Medusa or 450M. It is mechanically similar looking because the 8x8 antenna is built in. And as the Q&A floods in, we'll let Joe speak to that, but it supports 4.9 to 6135, 48 volt PoE, and a 4-wire DC in, SFP plus interface to support the high throughput, an 80 megahertz channel support, and 1024 QAM. This will work backwards compatible with current 300-25, and then the subscribers you'll see in the next slide. On the right-hand side, you see our 4x4 6 gig AP. Form factor will be very similar to the ePMP 3000. Frequency support, as you can see, 5.9 to 7250. So it will leverage the full 6E band, but have a little overlap into the 5.7 band, 48 volt PoE in, SFP plus, IP67, etc. But the other thing you see from the bottom, second bullet from the bottom, which if I turn on my laser, that will help, is 160 meg and 4096 QAM support. This is going to get very interesting here in the next slide as I talk through it. And of course, the power and whatnot is more or less maximum, and ultimately 6 gig will be dictated by your Eirp limits as defined by the FCC. So these are the two access points.
Sakit, there have been a couple questions flowing in, so I thought maybe we'd make it this a little interactive and bring those up now. So one of the questions that jumps out is why 8x8 in 5 gig and 4x4 in 6 gig?
Great question. So I think the way to think about this is the following. 5 gig is a congested band, where Moomaimo benefit is desperately needed, because you may not achieve the highest modulation, but you want to go after the advantage of a multi-user MIMO, i.e. 8x8. And your density of subscribers will tend to be higher in 5 gig because we've been in this 5 gig space for a long time. So now when you do an 8x8, chances of able to group subscribers and getting that Moomaimo benefit is much better. When you shift over to 6 gig, we're going to start in a relatively clean spectrum. And the goal there is that, you know, the subscriber module throughput, achieving that higher modulation and getting that high channel bandwidth to operate is a bigger focus. And because the density is not going to be that high initially, and you also have the Eirp limits and stuff, we opted to go with the 4x4 design, manage some of the costs around it. Remember, this is all new chipset, new hardware, so there's costs associated with it, and decided that a 4x4 system will more than suffice in something like a clean 6 gig spectrum while we push for an 8x8 on the AP. What you will see is, yeah, there's going to be other players that may come and say we do 8x8, et cetera, et cetera. But the name of the game at the end will be the performance, right? Whether it's the AFC coordination and higher modulation support and what kind of throughput you're going to get out of this system is what's going to really, really establish the dominance in this space. But hope that helps. That's the approach we took between 8x8 and 4x4.
There's another question here about have we considered, so the question is on the 5 gigahertz solution, we're showing a full 8x8 sectorized approach. Have we considered anything like some kind of an omni or a solution for micropops or smaller sectors?
Yes, we have considered it, and just to give you an idea, this is our very first webinar on this topic, right? So there is a roadmap that's behind this that we're not going to elaborate on today. We're just showing you the first set of products. We're certainly going to take your input and certainly going to look at other ways and work with ecosystem partners like we did in the past to create other variants of the AX-based AP. That will certainly happen. So keep those input coming.
Okay, just maybe hit a couple more and then we'll keep moving. There's a question about comments about we have PoE in and a DC in on the 5 gig access point. Question is, will those be redundant power options? Can they work in concert?
Hey, great question for Joe Steffen.
Yeah, the answer is yeah, you should be able to use them redundantly, correct. It's positive 48 volt in on the DC 4-wire.
Excellent.
Excellent.
And I think, oh boy, there's more questions coming in, which we love. So this is good stuff. Maybe we'll get into this later, Sakit, but it talks about, or there's a question about 4096 QAM and what's the channel conditions needed to achieve 4096 QAM.
We'll talk about that. That's a very exciting topic I want to touch on, actually.
Yeah. And then there's there was a couple earlier questions. Maybe I hit a couple of those real quick. So we talked about compatibility. So this will be, we'll talk about that in a little bit more detail as well, about compatible with the Force 300 SMs, but the short answer is yes. RF Elements products are not included in our Cambium price list. You work directly with RF Elements and their channel partners to get access to RF Elements antennas. Force 300 products, the question is, do they include a bracket with the radio? So yes, all of the ePMP radios have a bracket that you can do a pole mount, and in many cases a wall mount. So that's on the data sheets. You can see that that information. And then, and what is, and this might be one for the panel here. What's the typical range that we see for Force 425 and achieving the highest modulation?
Okay.
How do I get that gigabit per second, and what sort of the channel condition and range I can expect on that?
Right. So that's probably a great question answered by this audience. I mean, I can speak to it, but I think it's better if you look on our community, if you look on Wisp Talk, Facebook posts and stuff like that. There's customers constantly posting about 425 link distances and the throughputs and what you need. I won't give you an exact distance, but we have seen a couple of kilometers or a couple of miles, sorry, get to 1024 QAM. But others are getting the one thing I want to highlight, that's an important topic, is when we talk about the higher modulations, it isn't always about achieving the 4096 or 1024 QAM. But what you have to remember is when we built these radios to achieve those higher mods, it means the other modulations that were previously requiring higher SNR now has lower SNR requirements. So we see the radio sitting at 256 QAM for far better, weaker RSSI than we did in the past, right? So there's a gradual improvement in all previous modulations. So even if you don't get 1024 QAM, you get 256 QAM. Even if you don't get 4096 QAM, your chances of getting 1024 QAM becomes higher. But we'll share some data here shortly. But 425, I'm going to let the audience chime in the chat window and respond to some of this question. But there are customers that are deploying it in North America and globally and seeing some great performance.
All right.
Bruce, line up a tough one for Dimitri. That's your next task.
Okay, well, I'll have to think of one. I think I'm sure the audience here can come up with something to stump Dimitri, but it's not easy. I'm sure it can be.
Yeah, while you're looking for the question, so regarding the distance on the Force 25, so I would encourage everybody to go to the link planner, because it can give you the rough idea. You can play with different antenna sizes, and you can see when you will get high order modulations. The rule of thumb, if you will be in the higher 30s in terms of the signal noise ratio, you will probably get the highest modulation if there is no any interference. If you're on a clean channel and if you're in the higher 30s on the SNR, you will get it. But link planner is the way to go to answer the distance question, because the main thing that we don't know is the antenna size. So obviously, if you are going with a bigger antenna, you will go longer distance with the highest modulation.
All right, and here's a question that I think for you, Dimitri. What do you anticipate will be the subscriber module count, or the maximum number of subscribers on the 6 gigahertz 4x4 solution?
So currently we are targeting the same number of subscribers as we have on the ePMP 3000, meaning it's 120 subscribers. But we hear the requests to increase this number, so we will, getting closer to the release date, we might have a higher number of the subscribers available.
Okay.
On the 6 gig.
Great. Move on, Bruce.
Yeah, let's move on. There's more coming in, so but we'll take those in after a couple more slides. So yeah, let's keep moving with some of the other content.
Thank you, Dimitri. All right. So, and next slide. All right. So subscriber modules. Let's kind of go through this real quick. This is an important slide. So from the very far left, what you see is the 6 gig, what we call a high tier subscriber module, or potentially a point-to-point. Keep in mind on point-to-point, you're going to have that Eirp limit for standard power. But this is a product that is, in our hands. We're doing some lab testing. We actually have a deployment outdoor as well at 2 miles that I'll touch on a little bit. But it's a 5.9 to 7250 support, active PoE, SFP plus, et cetera, et cetera. The key thing I want to highlight with my laser pointer is that this is the one product that does support 4096 QAM and the 160 meg channel. As you move to the right, you'll see a 6 gig SM, which is going to sell at a lower price point because it doesn't have the 4096 QAM. And if you ask why that is, it's just fundamentally trying to create a few different tiers of subscribers and create an affordable line for the audience. But otherwise, it's more or less very similar design as going back to our Force 200 design with the right bracketry and a holder to carry it, and just kind of falling back to some of the things Joe did over the years to improve our industrial design. But this is supporting the same band, but it's a 1024 QAM 160 meg. You'll notice something that says USB GPS accessory versus an internal GPS. And disclaimer right away, we spent a lot of time making sure the GPS is in rock solid state. I know we've had challenges with GPS in the previous generation products, but this one has the internal. You can also plug in the puck, and we are introducing better pucks with better sensitivity and whatnot. On this one, when you see a USB GPS accessory, the idea is to leverage an USB port and plug in a GPS on the subscriber. Why do you need that? Because when you're operating in outdoor standard power, part of the AFC requirement is that the subscriber has to send location information to the AFC database. But if that rule changes at some point, for whatever reason, you don't need to have the accessory. So by doing it in a USB port, we're giving you the flexibility to add or not add. Needless to say, having GPS at a subscriber opens up other possibilities of location-based service offerings and things like that. On the 5 gig side, it's going to follow very much a 6 gig SM form factor. This will go to 80 meg 1024 QAM because in 5 gig standards, we don't support a 160 meg channel. But this is going to be that underlying OFDMA solution, right? Supporting multi-user Moomaimo and the 1024 QAM. It's going to be a very, very compelling and powerful subscriber module on its own right. But thinking about our ROW customer base, where ARPUs are challenged and cost points are interesting, we are going to create another derivative of the 5 gig where we're going to do some thermal throttling and things like that to bring down the throughput and cut some costs down and pass that on to the customer base. But again, this becomes a optional RW type SKU only.
Yeah, and just to add there that the difference is really the FCC has some specific filtering requirements that we have to build into that 5 gigahertz SM. So in addition to the subtle differences in the performance, that really is one of the drivers for why we have what you see referred to there as a row model in the other model. The other thing I just have to throw it out there, Sakid, sorry, but these are, I'll just say that these are very preliminary specs. It's indicative of what we're planning to do. We're not announcing these products today, but I just want to say, this is what the team is working to, and we're looking for feedback on these as well. And so your feedback is we're very interested in your feedback. But I will just say that these are, as we always have to say, these are subject to change until we actually announce the product and publish the data sheets and that sort of thing.
Yeah, this is by no means an official roadmap or anything. And Bruce, let's just come out and say it, right? The other thing is invest in your ePMP 3000 networks today, right? That's the product that's available. That's the subscriber you want to buy and put up. What we're showing you, the reason we're sharing this stuff is this is the next generation stuff. And we want you guys to consider Cambium as you think about what technology you're going to invest in next, right? Which brand you want to attach yourself to, right? Which brand gives you the biggest investment protection? So this is really the under the hood look to see that, hey, we are going to take care of you guys. We are coming up with a robust roadmap, but the focus should still be on what we're selling today. We've got a, not to segue too much, but there's going to be a 4.7 release, which is going to have this really cool DPI stuff that we're going to have a whole nother webinar about it. So there's a very powerful roadmap still on ePMP 3000 as that moves forward. So that still needs to be the focus today while we give you guys insight on the future stuff.
All right, let's take maybe 3 or 4 more questions here because there's a bunch coming in. I really appreciate it. Well, one is back on the access point. Have we considered an 8x8 6 gigahertz in the future if
Yes.
if there was demand for it? Yeah, so
Yes.
I think you just answered it. Yes, we'd consider that.
We definitely will, and it may be beyond 8x8. It may be a 16x16. I mean, there is another standard around Wi-Fi 7, right? 802.11.be that's starting to formulate. So as we ride that, we're going to fully leverage and reevaluate our ability to do higher order modulations and what makes sense for the market. So that's the short answer.
Yeah, there's an interesting question about, because that peaks up into the 7.25 gigahertz spectrum, is in some parts of the world that's a licensed band. Have we considered making it available as a licensed product? So interesting point. I think we may have to come back to you on that one, but it's an interesting data point to consider. So I'll just leave that one there. There's a question about, have we considered a form factor like the Force 300-16, that sort of that horizontal form factor? Have we considered that?
Yeah. Not only consider that, we fully intend to do so, just not, we just haven't started on that stuff yet, but it is under consideration.
Okay. And well, there's a question here. I'll toss this one out there as well. It's a general question around OFDM-A. And so in general, what does OFDM-A mean for this platform? And then secondly, how will it behave if you have some Force 300 subscribers connected, mixed in with these Force 11AX based subscriber modules?
Good one for Dmitry Moisev. Give us an education, Dima.
Can you repeat the question?
Yeah, so it's a general question about OFDM-A with the with this platform, and so maybe one comment about the introduction or use of OFDM-A, and then the second one is if you have a mixture of Force 300 SMs and the 11AX SMs, does that stop OFDM-A from working?
Okay, so OFDM-A, it's an exciting feature of the 11AX that we have. So the high-level idea of the OFDM-A and how we're going to leverage it in ePMP is to use so-called resource units. Basically, we will split the spectrum. For example, you're using 20, 40 megahertz channel, 40 megahertz channel. Then we can split it into multiple sub-channels. They are called resource units. And in this case, we can use those different sub-channels inside this 40 megahertz channel to send the data to different subscribers at the same time. So it's another dimension of the multi-user access to the air. And we can do it in the downlink to send data to multiple subscribers at the same time. Or we can do it in the uplink. So the main benefit of this, if you don't have a lot of load, you're not at the full capacity of the sector, but you have data to multiple subscribers, you can minimize the latency to those subscribers because you can send the data simultaneously to them without waiting for another TDD cycle, without waiting for another 5 milliseconds to send the data to another subscriber. You can send portions into different sub-channels to different customers. And the most useful thing for WISP community is the OFDM-A in the uplink, because the main usage data patterns these days is the downlink streaming, like Netflix, YouTube, and other video services. And they are consuming the most of the data. And for all this data, there is tons of acknowledgements from the subscribers. It's either TCP or even for the UDP-based protocols, there are still acknowledgements that are coming in the uplink direction. So if we're using OFDM-A, we can send those acknowledgements. Different subscribers can send their acknowledgements in different resource units. And basically sending a bunch of data in the downstream for different subscribers watching Netflix, we can acknowledge this data in one TDD cycle for multiple of the subscribers. So it gives us, again, the latency benefit and the throughput benefit for the, depending on the protocol used. So it's a really exciting feature that will eventually minimize the latency of the system.
Yeah, that's great, Dimitri. I think what the audience here is getting a sense of is just the amount of technology that's packed into Y6 and 11AX, these chipsets. We're going to be able to take advantage of that and leverage that. And I know the team is just really digging in and building out all kinds of great capabilities. And OFDMA is a key aspect of that. But lots of good stuff coming in this next generation. So yeah, go back, Saki. We've got some more questions, but we can pick those up at the end.
Yeah, let's move ahead. Sorry. Oh, sorry. Just when I move. Okay. So I give you a little preview of some performance and hardware specs. You know, numbers are great on paper, but even greater if you can show that in real world performance. So we hope to share a little bit of that here in a few slides. But as you can see, from a capacity perspective, we're looking at some substantial throughput numbers. Again, as Bruce had indicated early, as the software matures and all that, we may see some losses in some cases, maybe improvements in other cases. But some pretty compelling numbers once you start taking into consideration achieving the higher order modulations along with multi-user MIMO. Hardware specs, I won't go through this, but we kind of covered this a little bit in the earlier details. But you know, from a performance perspective, just wanted to highlight that you got a 4x4 Moomaimo with downlink and uplink OFDMA, and you have uplink Moomaimo that's also on the roadmap, and we're going to work on that. And overall, significantly better efficiency in throughput. And of course, our air fairness scheduling with the starvation avoidance mechanism we have, the different QoS levels, TDD scheduling, flexible scheduler, all of that is planned in the next months as we develop the software and work through all of this. And for the interest of time, I'm going to go ahead and move to a live, well, not a live system, but screen captures of a F600C, the 4600C, the 4096 QAM supporting product that we highlighted. But this is operating in 6125, 20 megahertz, transmit output power is 5 dBm. It's a lab environment. We just had a link go up in a location at 2 miles yesterday that in the next few weeks we'll start sharing more field data. But what I want to highlight to you is here, obviously this is really close, and there was a question earlier, but here the RSSI is NEC 43, real strong. But here in this environment, at that RSSI, you see 99% of all of our traffic going through 4096 QAM. And I'll answer that question that was asked before, like what is that RSSI that we can get to? And Joe and Dimitri can confirm, but we're seeing about NEC 55 to NEC 56 is the threshold up to where 4096 will continue to work, which I think is really, really phenomenal. And then we'll share more data on the thresholds for the different modulation levels along the way. So 20 meg channel, the throughput here is running a microtick data, and you're getting somewhere in the 250 meg performance. And I just want to see if my slide deck, give me 1 second, I think. Okay, some of the commentary disappeared as I copied and pasted this. But you can clearly see some of the performance numbers here. And then I'll go back to screen sharing. This is again now at 40 megahertz channel. You're pushing over 500 meg in the downlink plus uplink. When you start doing bidirectional, you can see 350, 350. So you're hitting close to 600 meg on a 40 meg channel in this case. Again, all is done with a microtick traffic generator. So this is not just a built-in link test. 80 meg here, you're starting to push 1.1 gig here, and bidirectional, you're sitting right around 600 on each direction. So you're getting up to 1.2. And then last but not least, the most exciting one at 160 meg channel, you're getting almost 2.2 in downlink and 2.2 in uplink. Again, this is in more or less the ePTP mode, so it's still a point-to-point product. But the key takeaway from sharing this with everybody is that you are seeing 160 meg channel operation with 4096 QAM hitting the 2.2 gig type throughput. So this is quite revolutionary, I would say. And because the link that we saw yesterday at a couple of miles hitting about a gig in each direction starts to show the potential for 6 gig to give that really, really high performance to your subscriber modules. As we go to point-to-multipoint, you're going to have another big ace up your sleeve, which will be the multi-user MIMO. But what we wanted to share is that the hardware is there, some software has been developed, and we're starting to see some of the key feature numbers and the high throughput that we would expect out of this platform. So I wanted to share this, and as I indicated just a few minutes ago, we'll start sharing more outdoor data as we move forward. And that's the end of the slide deck. So we have some time, Bruce. Maybe shoot some more questions and we can take it on as a team and answer.
Sure, we do have some more questions, and while some additional ones come in here, I wanted to mention a couple of things. If you are in North America and you are attending WISPAPalooza, we certainly encourage you to come out and see us at the booth. Both Sakid, Dimitri, and I will all be at the show. And on the Monday afternoon, which is the 11th of October, we'll be doing a ePMP Tech Talk, and we'll have a couple of hours to go into some of the features and things we talked about here in more detail. We'll talk about some of the software features that are coming in the ePMP 3000. We'll have some live equipment set up, so if you have questions about particularly how a specific feature works, that's a great opportunity. So that's called the ePMP Tech Talk. It's the 11th of October at WISPAPalooza. If you go to the Cambium Networks website, you can see a registration link there, and you can also register straight through the WISPAPalooza website. There's a section there for on-site events. There's no cost to that, and we really appreciate you if you would come out, and it's a good opportunity to get your questions answered.
Bruce, I wanted to also do a plug that Tech Talk. There's something else that's going to be quite interesting. We're going to talk a little bit about a Cambium QoE solution, quality of experience, and do some demos on that. So that's going to be very, very exciting. So if you are in Las Vegas, stop by and register for the Tech Talk. So that's going to be another exciting topic.
Okay, so there are some questions. Well, there's a general question about what kind of range can we expect with this next generation of technology, just in general. Anybody want to jump on that?
I think again, the thing you got to keep in mind, and again, as Dimitri highlighted, Link Planner is a great way to look at this, but you do have an Eirp limit with 6 gig. So if you specifically think about 6 gig, that's the best way to calculate that. But as I mentioned, we see a 2-mile link with gig throughput in each direction. We're just getting some more data, and we're going to have some results out of our labs in Cambium as well. And the 5 gig, same concept, right? The ranges are going to be similar to what you see in 5 gig today. But as we indicated, we'll share the minimum RSSI requirements as well to hold 1024 QAM on the 5 gig side, so you get an idea of what type of RSSI you should be looking for. But we expect that, or at least the data indicates that the RSSI requirements are just getting better and better in terms of hitting the higher mods.
Okay. Well, let's see. There's a question about, and this might be a general ePMP question, but it's really around the TDD cycle and uplink downlink ratios that we support. And the question here is, could we support 85/15?
Dimitri, we have a further granular duty cycle, right?
Yes, but we don't go into the 85/15, and the reason why we don't have it, because in most cases you might think that you don't have a lot of data in the uplink for the customers, but we have to do the acknowledgements. Not we, but the protocol used by Netflix, YouTube, they do have acknowledgements. And those acknowledgements, they have to be sent in the uplink. And if you have a lot of acknowledgements, although they don't they are quite small, and they're not using a lot of bytes, but they're using a lot of time, because you have a lot of subscribers, especially going to 120 subscribers. You're having a lot of subscribers doing acknowledgements, and each acknowledgement, it has the overhead for the data transmission. Although the packet itself is quite short, but you still need a lot of time for those subscribers to send the data in the uplink. So if we calculate the worst case scenario with the 120 stations and go into 85-15 ratio, we will just not have enough time to send the uplink acknowledgements in the reasonable time. The latency will go through the roof. So that's the main reason why we're not going into 85-15 ratio.
Okay. Let's see. There's a there's a question here about there's no mention of 2.4 gigahertz in any AX product. Anybody want to comment on that?
Well, I mean, we've seen this argument in the past too, Bruce. I guess it's an open discussion, but
Sure.
2.4 obviously is not a lot of channels, and it's extremely crowded with lots of devices that in our homes are still running on 2.4 apparently. But it's something that's on a distant roadmap consideration. If we see 2.4 getting evacuated because everybody's moving to 6 gig and whatnot, it frees up a little bit. It's a high quality spectrum, right? So we may come back and revisit that. But that's probably the best I can tell you right now.
Okay, and you know, I guess we knew this question would be coming, and there's about 6 different ways it's asked, but what can we say about when?
I think, Bruce, I think we kind of addressed it, right? If you think about 6 gig, all we have to say is that, and I'll answer both questions separately, but when you look at 6 gig, I showed a timeline that is dictated by the AFC certification, and our standard messages will be in sync with that timeline. So that's on the 6 gig stuff. The question on 5 gig is, look, when we launched ePMP 3000 and we had backwards compatibility, it took some time to bake it, and some of you guys were instrumental in helping us cook the solution. So without going to specific details, I would expect that second half of next year is when we start engaging with customers to start cooking the 5 gig AX solution. When the official launch and all of that will happen, can't comment on that right now, but all I can tell you is that sometime middle of next year onwards, you'll start seeing Cambium coming out and engaging with customer base on doing betas, trials, and etc.
All right. And the other question we knew would be coming, you can guess, is what do we expect the pricing of this to be? And I think the short answer to that is we have not established pricing on this product line yet, although it is our ePMP product line, and we expect it to be you know, quite competitive in this space. And I will also say that because of the higher order Moomaimo and some of the new technologies, that it will be priced higher than the current ePMP. But we know that this needs to be market competitive, and we're aiming to hit that mark. So I know it's not too satisfactory of an answer, but that's where we're at, and we don't have any pricing to share today. There was some more technical questions though. Back on OFDMA, there was a follow-up on mixing Force 300 or 11AC SMs with 11AX SMs, and whether that would preclude or eliminate the ability to do OFDMA. And we may just not know the answer to that yet. So if we want to you know, push that down the road a bit, we could. Dimitri, do you want to comment on that?
You complete the 5th.
Yeah, you're absolutely right that there are still some unknowns around the cool features like OFDMA. So please.
Yeah, we'll come back on that one. I think it's a good question. The compatibility will certainly be there to interoperate with Force 300 SMs, but all of the different combinations and permutations we're still working through. Let's see. Well, here's one. Will we be able to use the Force 425 and Force 400C, which today are point-to-point products? We'll be able to use that hardware as a subscriber module on the 5 gig next gen. And so the answer to that is, I believe the answer to that is yes, unless there's late breaking news, but that is certainly the intent. Any comment on that, Dimitri?
Yeah, you're absolutely right. There will be nothing stopping you from using them as a subscriber.
Okay. There's a question about link planner support. So certainly link planner will be available for to do planning for these products, but it's not in the current release and not in the next release. But it'll be available in line with when we bring these to market. So certainly link planner is key to that.
I believe Force 25 and 400C, they are supported by link planner.
True.
By the latest version.
You could get a flavor for AX performance is a point-to-point link with the current link planner. That's a good point.
And if you want to simulate, you can try a PDP link with Force 25 and putting some low gain antenna on one side and having it like thinking that it's like a sector type of antenna.
Okay. And here's one. I think we have some. There's a question in here about have we, and this is for you, Dima, as well. Do we have any capability to do bug reporting? Like if a system was to crash and collect that information from the crash, is there any way to automate that process?
Right. So we do have a feature right now on the devices. I think it was introduced in 4.6 release. So when you log in first time after update to 4.6, it will ask if you agree to send the anonymous crash reports. And if you agree and say yes, then in case the device crash, it will send the data to the cloud. So and in the cloud, and those are completely anonymous. So there is no customer information in those crash reports. We don't even have the configuration of the device or anything like that. So it's just the crash report, and we can analyze it and we can work on fixing it. And since we released 4.6, we've got a number of those crash reports back, and we already fixed probably almost a dozen of them. So it was a huge help. So everybody who is using ePMP, please say yes to the question if you want to send those crash reports.
That's great. Yeah. Okay.
More importantly, upgrade your network to the latest release, please. If you're behind, please upgrade, because I think our 4.6 base release have been very stable, and there's a lot of benefits to moving to the latest release. So that's a big ask from us.
And if you are running on 4.6 release, please go and update to 4.6.1. It's just a bug fix release, so there is no new functionality, but there are a lot of very important fixes that will make your system more stable, and you will get more throughput in some cases. So it's a must.
Okay, let me just, we're over time, but there's one, let me just see, I think there's one other question I think would be good to answer, which is, in North America, what do we see the Eirp limits in 6 gigahertz, both for the AP and the SM? Specific question was, is the 6 gigahertz SM Eirp limited to 30 dBm?
So currently, there is no available regulation officially posted by FCC. And that's the answer. There is no official answer as for now. The rumors are that, well, not the rumors, the working groups working with FCC to make this happen, telling us that there will be two types of the subscribers, like a standard power and the high power subscribers. And there will be additional requirements for the high power subscribers. For example, having the GPS antenna and work with the AFC system to coordinate the frequencies. So the high power subscribers, they will go almost as high as the AP up to 36 dB. And the like a standard power will be 30 dB.
Okay.
Eirp
All right,
Limited.
so yeah, so I guess the short answer is that because it hasn't been officially sanctioned, and there's no products, the FCC has not certified not only the rules for 6 gigahertz, they certainly haven't certified any products in 6 gigahertz. So
For the outdoor.
For the outdoor.
for outdoor, absolutely. Yeah, I'm talking about fixed wireless for the outdoor for sure.
The expectation is standard power, 36 dBm is what we're going to aim for. Our products are designed to go there. Just a matter of getting that finalized and final guidance from the authorities.
Okay. All right, and I think that about covers it. If you have additional questions, please go out to the community and pop them up there. Riley will be posting the recording of this up on the community, so you can comment right there on the recording. Also, again, consider coming out and seeing us at Wispapalooza for the Tech Talk on that Monday. And if you can't make it on Monday, stop by the booth. And also Monday night is the Cambium Networks open house. That's always a must-see event because you'll hear about these products and many more that are coming from Cambium. So make sure you come out to the open house on Monday night at Wispapalooza. I think that's it. Thanks to everybody. Skeet or Deemer or Joe, anything else you want to comment? Otherwise, we can bring it to a close.
Thank you, everyone. Thanks for joining. And those of you that are coming to WISPA, see you then.